Okay, the last part of this section is on one-to-one and onto linear transformations. One-to-one and onto, these are concepts that apply to functions in general, not just to linear transformations. So I want to talk about the definitions to begin with, dealing with just plain functions that go from R to R. And after we do that, then we'll talk about what this means in terms of linear transformations. All right, so first up, recall, a function is a rule that assigns one output value to each input value. So, in terms of, graphs like this, it means if it's a function, it passes the vertical line test. Now, a function is one-to-one if no two x values get mapped to the same y value. And so, in a y equals f of x type function, this means it passes the horizontal line test. So for instance, these three functions that I've got drawn here, this one is not one-to-one, and this one is not one-to-one. But this one over here is, because any line you draw through here is going to hit it in exactly one place. So this is one-to-one. This is not one-to-one. This one is not one-to-one. And again, the reason is over here we can find, if I draw a horizontal line through here, what we're doing is we're finding a particular value of y that multiple values of x map to. And the same thing over here. That's just one example of a y value. I guess that's 2 that's mapped to from two different x's. Okay, onto is a different idea. A function is onto if every point in R shows up as a y coordinate. So if we look at these functions, I don't have the whole things drawn, but the question here is, does the function cover every possible y value? This one is onto, because this thing, it keeps going up and down. It's going to hit every possible y value. Same for this one. This one's onto. But this one is not onto. And it's because we don't hit the negative y values. So onto, when we're just looking at things that map from R to R, that's all we're looking for is, do they hit all of the y values? Another example, if you had f of x equals sine x, this one is certainly not one-to-one. And it's also not onto. It's not one-to-one because we can find any value between -1 and 1 gets used infinitely many times. And it's not onto because we don't have every single y value showing up. We only have the y values between -1 and 1. I want to look at linear transformations now. So a linear transformation is one-to-one if no two vectors in V get mapped to the same vector in W. And it's onto if every vector in W is the image of some vector under T. Another way of saying this is it's onto if the range and codomain are equal. So I want to look at several examples here. First up, I want to look at 3 examples that are fairly easy to look at and determine if they're one-to-one or onto. And I say fairly easy, at least something that with a bit of guidance you can see that it's one-to-one or onto or not. And after we do these 3 examples, we'll look at some techniques for determining if something is one-to-one or onto. So let's start with this one. This first linear transformation maps R2 to R2 t of xy is equal to 0, y. Now, you could probably look at this immediately and say this is not onto, because we can't get everything in the plane as the output of this function. The only things we're going to get as output are vectors with the x-coordinate of 0. So this is not onto, because the range is just the let me draw a picture. If, say, we had this point here, and this point here, and this point here, when we stick these points into the linear transformation, the y-coordinates don't change, but the x-coordinates go to 0. So this guy moves over there, this guy moves over there, and this guy moves over there. So it's definitely not onto, because we only get the y-axis instead of the entire R2. Now, is it 1-to-1? I think you can see again that it's not 1-to-1, because any one of these points on the y-axis has a lot of things that get mapped to it. This point right here has as its pre-image anything that's on that horizontal line there. So it's also not 1-to-1. Because we can find many pre-images for any particular point. Okay, let's look at this next one, the reflection transformation. T of xy equals yx. So first off, let's think about onto. Is it possible to get any point in the plane with this? Absolutely. If you want to get the point yx, you just, for the pre-image, you just swap them. To get any point as image, or maybe a better way of saying that, to get any point as t of xy, just swap y and x. Maybe that's still a confusing way of saying it. But anyway, give me a random point. If this were a class, I would ask for a random pair of points. Let's say 3, 7. So can we get 3, 7? Absolutely, just by putting in 7, 3. And that's true for any value we want. So it's definitely onto. Is it 1-to-1? Yes. If you think about what this does, it flips everything across this line. So it's going to just transform the plane onto itself by flipping over. So you can't find any point over here that has more than one pre-image. This point is the reflection of that point there. So it's also 1-to-1. Okay, what about this one? This one might be a little tougher to think about. It says the transformation T maps R3 to R2, and T of xyz is x plus z and then y. All right. Let's look at 1-to-1 first. Is it possible to get one point over here using two different input values? And I think the answer there is yes. Let's say we did T of 3, 0, 5. Well, the image of that is x plus z, so that's going to be 8, and then y, 0. Can we find another point that gives us 8, 0? Yeah, the y-coordinate is going to still be 0, but we just need to put in an x and a y that's anything that adds up to 8. So you can put in, say, 7, 1, or 6, 2, or 10, -2, or whatever. So this is not 1-to-1. Then what about, is it onto? Well, can we get anything we want here? Well, if you wanted to find any random point, then definitely you could. Let's say I'm going to pick a random number, 5, 20. Okay, in order to get that, we'd put 20 in the middle. And then how can we get 5? Well, we just have to pick two numbers that add up to 5. So 4 and 1 is one particular thing. So yes, it is onto. Now to prove that it's onto, we'd have to show sort of a recipe for how to pick this. And I'm not going to go into that. But this is onto, and I think we can see it. Now a good question is, what if it's not easy to see? And if it's not something that you can just look at and tell, we've got a couple of facts that'll guide us right through that. But we'll save those for the next video.